I've got another indefinite integral up here on the board. Want to just point out that once again, I have all of my clues that I might want to use a u substitution. First of all, I have a product of two functions. I've got e to the x times secant squared of e to the x. Do be very careful. This is not secant squared times e to the x. Trig function has to have an input. There's only one x. This can't be a product of two functions. This is plugging e to the x into the secant squared function. And that's the second thing I'm looking for. One of the factors is a composition. Okay, so that's e to the x being plugged into secant squared. That's actually a multi-step composition because I'm plugging e to the x into secant and then I'm plugging that into the squaring function. Okay, but if I think of it as just e to the x being plugged into secant squared, then e to the x is my inside part. Its derivative is e to the x, which is the other factor. So this looks like a great setup for a u sub. Okay, so I would suggest that you pause the video and give this one a shot. Welcome back. Okay. We said our inside part was e to the x. If this is going to work, I'm going to need to have the derivative, u prime, e to the x hanging out, and I do. And so then du is going to be e to the x dx. It's always just the derivative times a dx. So this piece and this piece together consolidate to become a du. And then this becomes my integrand, secant squared of u. You may remember as we were starting integration, I said it's kind of important that you write that symbol. Starting to be very important that we write that symbol because it tells me that's what I'm treating as my variable. So hopefully you have not developed the bad habit of forgetting to write your d whatever. Okay, but if you have gotten into that habit, break it now. You always need to have a differential to tell me what's the variable with respect to which you're integrating. Okay, so now I've rewritten this in terms of this new variable u. I recognize that secant squared is just the derivative of tangent, so an antiderivative will be tangent of u plus c. Okay. And then that's in terms of this new variable u. I'd really like to have it in terms of the original variable, so I just use the fact that u was e to the x, and this is going to be tangent of e to the x plus c. Excellent.